NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams. The most powerful space telescope ever built was declared technically impossible when it was first proposed. It came within a single vote of cancellation. It ran a decade late. It cost 10 times its original budget. And on Christmas morning, 2021, it launched perfectly, on the very first attempt. This is the story of the James Webb Space Telescope. And by the end of this video, you will understand not just what it found, but how something this improbable came to exist at all. For 30 years, the Hubble Space Telescope was humanity's window to the cosmos. It helped confirm that the expansion of the universe is accelerating. It photographed galaxies 13 billion light-years away. It showed us stellar nurseries, colliding galaxies, and the slow death of suns. It was, by any measure, one of the greatest scientific instruments ever built. But Hubble has a fundamental limit. It sees invisible light, the same narrow slice of the electromagnetic spectrum your eyes use. Dust clouds block it, and the oldest light in the universe, the light from the very first stars and galaxies, has been stretched by 13 billion years of cosmic expansion into infrared wavelengths that Hubble was never designed to detect. To see that light, to reach the beginning of everything, you need a telescope that sees in infrared, colder, larger, and placed at a point in space where no astronaut can ever reach it to make repairs. In 1996, NASA decided to build one. The estimated cost was $500 million. The planned launch date was 2007. Both of those numbers were fiction. The first break by 2010, the project was in serious trouble. NASA commissioned an independent review panel. Its findings were alarming. The telescope had 344 single points of failure. 344 places where one malfunction, just one, would end the mission permanently with no possibility of rescue. The sunshield alone, a 5-layer membrane the size of a tennis court that had to unfold in deep space to keep the telescope colder than the surface of Pluto, required 139 release mechanisms, 70 hinge assemblies, 8 motors, and roughly 400 pulleys to succeed. In the correct sequence, in a vacuum, 1.5 million kilometers from Earth. John Morse, NASA's Astrophysics Division Director at the time, put it plainly. The telescope had grown into something with no margin for error and no plan for what to do if that margin ran out. In 2011, the United States House Appropriations Subcommittee voted to cancel the program entirely. The Senate refused. Scientists across the country, many of them having spent entire careers on instruments that might never launch, organized, testified, and lobbied until the program survived. Why did they fight that hard? What did they believe was waiting on the other side? Webb's primary mirror is 6.5 meters across, too large to fit inside any available rocket fairing in its fully expanded form. The solution: 18 hexagonal segments of beryllium, each coated in a microscopically thin layer of gold, designed to fold into the rocket's 4.57-meter fairing and then unfold in space with a precision measured in nanometers. The gold is not decorative. Infrared light reflects off gold more efficiently than almost any other material. The beryllium is not accidental. At -233 degrees Celsius, the temperature Webb must maintain to detect the faint heat signatures of ancient galaxies, beryllium holds its shape without warping. Any other material would distort. And the sunshield, 5 layers of a polymer called Captain, coated in aluminum and silicon. Folded, it fits inside the rocket. Unfolded, it spans the size of a tennis court. Its job is to keep one side of the telescope scorching hot and the other side colder than Pluto, simultaneously, forever, with no moving parts once deployed. Detecting a dimethyl sulfide signal from a planet 120 light-years away is something like standing in London and smelling a single candle burning in a house in New York. That is what Webb is doing, across the void with light. On December 25, 2021, an Ariane 5 rocket lifted off from the Guiana Space Center in French Guiana. The launch was so precise that Webb used less propellant than projected, potentially extending its mission life from 10 years to more than 20. What followed was what engineers quietly called 29 days on the edge. The sun shield deployed over 8 days. The secondary mirror unfolded. All 18 primary segments pivoted into their final positions. Every step was broadcast live. Every step was irreversible. There was no repair mission, no abort, no second attempt. All 344 steps succeeded. On July 11, 2022, NASA released the first image at a White House event. The full suite followed on July 12th. One of them, a gravitational lensing field called SMACS 0723, showed thousands of galaxies as they appeared 13 billion years ago, packed into a patch of sky the size of a grain of sand held at arm's length. Hubble's image of the same field had required approximately 10 days of exposure. Webb captured it in 12.5 hours. Then, Webb found something that stopped cosmologists cold. Massive, fully formed galaxies existed when the universe was between 500 and 700 million years old. Galaxies that our best models of cosmic evolution said could not have assembled themselves that quickly. Astronomer Mike Boylan Colchin calculated that 6 of the largest candidates pushed against the absolute physical limit of what standard cosmology permits. Then Webb did something no telescope had ever done before. It read the atmosphere of another world. Using a technique called transmission spectroscopy, measuring starlight as it passes through a planet's atmosphere during transit, Webb detected methane and carbon dioxide in the atmosphere of K2-18b, a planet approximately 120 light-years away. In the same system, it also detected a tentative signal for dimethyl sulfide. On Earth, dimethyl sulfide is produced by exactly one category of thing: living marine organisms. In a separate system, it detected sulfur dioxide in the atmosphere of WASP-39b. Scientists remain careful. Some of those early galaxies turned out to be active black holes whose accretion disks were mimicking the brightness of billions of stars. The dimethyl sulfide signal is unconfirmed. Webb has not found life. But here is what it has done. It has made that question, for the first time in the history of science, genuinely answerable. On the evening of July 11, 2022, scientists at the Space Telescope Science Institute in Baltimore sat in a building holding images no one outside had seen. Some of them had worked on this project for 30 years. They had survived the cancellations, the 344-point failure audit, the fasteners that came loose during acoustic testing in 2018 and set the program back approximately 6 months. 6 major programmatic delays in total. A global pandemic that halted final integration at the contractor's facility for months. Jane Rigby, Webb's senior project scientist, later described the moment her team confirmed the first data. The images, she said, looked fake. So clean, so sharp, so far beyond what their models had predicted that they spent time simply convincing themselves the telescope was actually working. Approximately 10,000 people built this telescope across more than 2 decades. Welders, optics technicians, thermal engineers, software architects, project managers who held the program together through a congressional cancellation attempt that nearly ended everything. Their names will not appear in any headline. What they built will operate, if everything continues as planned, until the year 2041 or beyond. Every image it takes between now and then is an image that would not exist without the decision made by thousands of people over 30 years to keep going. Webb was expected to resolve one of cosmology's deepest disputes, the Hubble tension. Two independent methods of measuring how fast the universe is currently expanding give systematically different answers. One says 67 kilometers per second per megaparsec. The other says 73. In a field where measurements are typically precise to within 1%, a gap of 8% is not a rounding error. It is a signal that something in our model of the universe may be wrong. Webb's 2024 data confirmed the higher number with greater precision than ever before. The gap did not close, it hardened. Adam Rass, Nobel laureate and lead of the direct measurement team, stated plainly, "The discrepancy suggests our understanding of the universe may be incomplete. So here is what we do not know. What is causing the expansion to accelerate faster than our equations allow? Is there a form of dark energy we have not yet imagined? And if the universe is stranger than our best models, what else have we been wrong about?" In the 1990s, cosmology faced a different crisis. Measurements suggested the universe was younger than its oldest stars. That contradiction seemed fatal. Then came the discovery of dark energy, and the whole picture reorganized around something nobody had imagined. Crises in physics feel like endings. They almost always turn out to be doors. James Webb Space Telescope was declared technically impossible. Then it was built. Then Congress tried to cancel it. Then it was saved. Then it launched perfectly on Christmas morning. Then it showed us galaxies that should not exist, the atmospheres of worlds we will never visit, and a universe expanding faster than our best equations allow. Every image it sends back is not a confirmation of the universe we expected. It is a revision. The cosmos does not owe us the version we modeled. Webb is teaching us to read the version it is actually telling. 30 years, $10 billion, 10,000 people, 344 steps that all had to work. They did, and the universe has been answering ever since.